This Zoom session is being brought to you by the fractal Odd Dyadic Horizon, BL. Another one of my recent one, also fairly nice and favorite one for me. We proceed. Today we will discuss trigonometric identities, some of them, and some basic identities, and how to derive other identities from them. Because there's a right way to determine an identity, and there's a wrong way. Well, there's two right ways and one wrong way. Okay, and an identity is basically a equation that's true for all values of the variables. So we've already gone through a few. Tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, cosecant is 1 over sine. There's also Pythagorean identities. I mostly focused on this one. Sine squared plus cos squared equals 1. If I divide this throughout by cos squared, you get tan squared plus 1 equals secant squared. If you divide this throughout by sine squared, you get 1 plus cotangent squared equals cosecant squared. There are parity identities. A trig function of negative theta is related how to trig function of theta. For cosine and secant, cosine negative theta equals cos theta, secant negative theta is secant theta. These are called even functions. They absorb the negative sign. Sine, cosecant, tangent, and cotangent transmit the negative sign. It goes outside. So sine of negative theta equals negative sine theta. Cosecant of negative theta is negative cosecant theta. Tan negative theta is minus tan theta, and cotan negative theta is minus cotangent theta. Just a second. All right. These are called odd functions. Co-function identities, where a trig function of theta equals its co-trig function of the complement. Cos theta equals sine of pi halves minus theta. Sine theta equals cosine of pi halves minus theta. Similar with tan to cotangent, cotangent to tangent, secant to cosecant, and cosecant to secant. So trig of theta equals cotrig of pi halves minus theta of complement of theta. Now, okay, this section is a little unusual in that it asks you to prove identities. Here, it's not enough just to simply say it's true or false. I actually require you to go through the steps. And there are correct ways to go through the steps and in an incorrect way. One correct way is by direct simplification from one to the other to prove that A is identical to Z. Oh, and by the way, if you write it A three lines like this, it means identical, not just equal. So you start from A and you simplify that to B, and you simplify that to C, you simplify that to D, and in the end we get Z, and therefore A is identical to C. That's one way. Another way is you simplify them to the same thing. So A is identical to B is identical to C, is identical to L. Z is identical to Y is identical to X, is identical to L. And therefore A is identical to Z. You can think of this as basically this if you start from A, go down to L, and then go back up to Z. The difficulty is that usually the simplification steps from A to L and Z to L are easier to see and to do than the unsimplification steps from L back to Z. So, for example, prove that 1 plus tan squared equals secant squared. All right, we start with the left side. 1 plus tan squared. That's 1 is cos squared over cos squared. Tan squared is sine squared over cos squared. Okay, next step, we add these two fractions. Common denominator is cos squared, and the numerator is cos squared plus sine squared. Then we simplify that. Cos squared plus sine squared equals 1. So you get 1 over cos squared. That's secant squared, and we're done. The left side is identical to the right side. Now this one is a little more complicated. That's using the first method, direct simplification from one to the other. This second one involves simplification to the same term. So prove that 1 plus tan v over 1 minus tan v is identical to cotangent v plus 1 over cotangent v minus 1. Well, okay, so here's what we do. Start with the left side. That's 1 plus tan over 1 minus tan. Tan is sine over cosine. So 1 plus sine over cosine divided by 1 minus sine over cosine. Multiply above and below, numerator and denominator, by cosine. 1 plus times cosine is cosine, plus sine over cos times cos is cos. In the denominator, 1 times cos is cos, minus sine over cos times cos is sine. So you get cos plus sine over cos minus sine. That's the left side. The right side, cotangent v plus 1 over cotangent v minus 1. Well, cotangent is cosine over sine. Here's a +1. Here's a cotangent v, cosine over sine -1. Cos over sine +1, all divided by cos over sine -1. We multiply numerator and denominator by sine v, and that too simplifies down to cosine plus sine over cosine minus sine. These are identical, therefore the left side is identical to the right side. That proves it. So does this. However, here's a way not to prove an identity, and that's by begging the question. That is, you assume the identity is true, you just write it down, then you simplify both sides till you get 3 equals 3. Well, that almost looks right. And even worse, right, left side equals right side, and then transpose terms until you get 3 equals 3. Well, the problem is that's not valid reasoning. You can derive a false state from a false statement. You can derive from it by invalid methods a true statement. So that doesn't prove the false statement. For example, suppose I wanted to prove that -1 equals 1. Well, let's just assume it. Then square both sides, that's valid, and get 1 equals 1, which is true. But just because you can get that 1 equals 1 from -1 equals 1 doesn't mean that -1 does equal to 1. Because if it were, then credits would be debits. We proceed. So, for example, let's prove the identity. 3 sine squared theta plus 4 cosine squared theta equals 3 plus cos squared theta. Well, the left side here, 3 sine squared plus 4 cos squared. We'll break this 4 cos squared into 3 cos squared plus cos squared. So 3 sine squared plus 3 cos squared plus cos squared. And these first two terms factor out of 3. So 3 times sine squared plus cos squared, that plus cos squared. Sine squared plus cos squared equals 1. So you get 3 times 1 plus cos squared. And that's 3 plus cos squared, which is the right side. And so therefore the left side is identical to the right side, and we're done. Here, let's prove that tan theta minus cotangent theta over tan theta plus cotangent theta equals sine squared minus cos squared. All right, now the left side, we'll write tangent is sine over cosine minus cotangent is cosine over sine. Tan is sine over cosine plus cosine over sine. Multiply numerator and denominator by sine times cosine. So when you do that, here the cosine cancels and we're left with sine squared minus cos over sine times cosine. Sines cancel, leaves a cos squared. Sine over cosine times cosine is sine squared plus cos over sine times cosine times cosine is cos squared. Now, okay, sine squared minus cos squared over sine squared plus cos squared. The denominator equals 1. Then we get rid of it and get sine squared minus cos squared. And that's the right-hand side, and we're done. The left side is identical to the right side. Oh, and by the way, in subsequent sections, I guess the second section from now, it turns out that this sine squared minus cos squared is I got it backwards, is minus cosine of 2 theta. But we'll get to that later. That's called the double angle formula. Okay, I think we are done for now. Let's call it.